Okay, let's begin. Everyone hear me okay? I said, can you? Oh. So I'm very happy to be here at YAMST Europe. This is always one of my favorite conferences. And really fun talk coming up today. This is about some stuff I've been working on for the last year or so. So who am I? I am a Perl 6 hacker. I'm one of the Recruiter core developers, which means at the moment I'm sort of in recuperation after we got Recruiter Star out. I work on a bunch of easy stuff like the object model, the type system, multiple dispatch, and signature handling. I like to travel, and a lot of these are to blame on Perl events. And actually the westernmost point and the easternmost point are. One was for YAMST Asia and the other was for OSCON. And I like beer. So the plan for today's talk, the basics, the not so basics, the mildly mind-bending, and the oh my god awesome. So I want to start out by just showing you some basic Perl 6 signatures. And to do this, I'm going to show how we'd write it in Perl 5, and then how it's going to look in Perl 6. So to start off with the positional parameters, well, we could just unpack the @_ array in Perl 5. In Perl 6, you just take these and you stick them there in a signature. So that's just saving us a little bit of code straight off. And you maybe would have taken the things into a hash instead, so you could name parameters. Well, in Perl 6, the syntax for that is just put a colon before it. And then when you call it with the fat arrow, which actually makes a pair in Perl 6 rather than just being a comma, then it will bind the parameter named country to there. If you actually just want to slurp up all of the parameters that you have, then you can do that as well. We call these slurpees because they just suck everything. And if you just put a star before it, then that's gonna slurp up all of the things you passed. And actually this example I actually want to talk about just a little bit. So the idea here is that we're getting a list of places, and these are objects that have a latitude and a longitude attribute. And we want to sort them kind of west to east, so we're just going to sort by latitude. Now, we can write a block like this. And what's going on here is we're using the this syntax here with the pointy hat is called a placeholder parameter. And what we're doing here is we're saying, I'd like this block, these curlies, to actually be a block that takes 2 parameters. But we could call these anything we want. And actually, if we wanted to sort east to west, we could swap the $B and the $A around. And it actually takes all of these $hat parameters, sorts them lexicographically, and then binds them in order. So we could write it like that, but actually, Perl 6 lets us write it like this instead. And what happens here is we provide an arity1 closure, which takes the place and just says, oh, I want to just extract this latitude value. And then it just goes and does a normal comparative sort on all of those numbers. So we have an arity1 sort, and as if that wasn't kind of nice enough, we actually have this star.foo syntax, which generates a closure like this, like this one here. And that means that we can just write it as return places.sort star.latitude. So that's kind of a nice big improvement. Back on topic, we can also slurp up all the named parameters as well. So this should just be like assigning @_ to a hash. And you'll notice that I've done something else shiny here. This thing over here, this plus in the square brackets, is called a reduction operator. And all we're going to do is take all of the values from this hash, and we're just going to add all of them up. So that's just a way to add up all of the hash values. Now, one of the things that we also get out of writing these signatures is we get some free checking done for us as well. So if we fail to pass enough parameters, then it's actually going to complain at us, the same if we pass too many. So in this case, I've got a subroutine that takes 4 parameters. I've only got 3 arguments passed here, I've missed out the time. And it comes to me and says, oh, I expected 4, I got 3, and it'll tell you what subroutine it was in, and it'll tell you where you called it from as well. Now, you might be thinking, what about if I maybe want to pass something or maybe not? Well, that's an optional parameter. Just like in regexes, you can write question mark to mean 0 or 1 of them. Well, you can do just the same with parameters there. That question mark there. And the other way to make something optional is to say, if it's not passed, I'd like to give the default value. So here, if I want to sort a bunch of cities, so if I want to get the biggest city in the country, then I could either call this with just the country name, in which case it will default to showing me the first biggest city, or I'd like to be able to pass along a value saying, which rank, so the second biggest or the third biggest, or so on. The optionality of name parameters is actually the default. So for the positional ones, the ones we have to call on, you must pass them unless you mark them with a question mark. We tend to use named parameters when we want to give you some extra little options. So they're not really kind of the core data you want to operate on. They work a little bit more like adverbs. So, it's like if I said, read the book, or I could have an adverb like quickly read the book, and your quickly in this would be kind of a named parameter. So here, if you actually want to require a named parameter, you just stick the exclamation mark after it. And so in this case, from, to, and date would all be required. Now, one of the important differences in terms of semantics of this between Perl 5 and Perl 6 is that we actually bind the parameters. So in Perl 5 you get a copy of them in @_. In Perl 6 they're actually bound, and they're read-only aliases to the things that you pass. To look at this another way, it's as if you're passing everything by backslashing it and passing it as a reference. So if we go and write code like this, where we take a amount parameter and we try and modify it in place by assigning to it, this is going to come and complain at us. It's going to say, oh, you can't assign to a read-only value. And it's going to tell you why you did this. So there's two things we can do that actually make this code work if we wanted it to. One of them is to say, I actually want you to give me a copy of the value local to this subroutine. And in that case, we just write isCopy. This thing here is called a trait. And then we have an actual value amount which we can modify in here. This doesn't affect the original value that we passed in. If you actually want to take something and modify the original thing, then you just say isRW, short for read write. And this is just going to actually let you modify the original thing you had. So this actually takes an amount in and modifies it in place. So if we say price at the end there, that price that we say is going to be the value that we assigned from the subroutine. So we're actually defaulting to kind of a much more pure kind of functionally thing. And you kind of need to say if you want to be able to modify things. The upshot of this is that if you pass arrays or hashes, then it's just like passing those by reference as well. So here I have a signature that takes an array and a hash, and I can just pass in an array and a hash, and they just stay like you'd expect them to. So again, it's like you backslash them and take a reference. So that's the basics. Now it's time for some not so basics. Types. So in Perl 6, every type of value knows what kind of thingy it is. And we have this macro called .what, which you can write after any variable or just any value. And it returns something called a type object. And the type object is an object which can sort of stand in for anything of that type. And interestingly, if we stringify it, in this case just by saying it, then it outputs the name of the type. So here, I can see 42 as an int, camel as a string, and so forth. And I can then start to actually write these type names against my parameters. So here I can just say, okay, I take a string from a string to, these will be place names, and I just take an integer number of kilometers. And this enforces checks for me. So if I call it correctly with 2 strings and an int, it works just fine. If I accidentally call it with the distance first, it's going to say, oh, I really wanted an integer there, but you gave me a string. And you'll get this error here at runtime. Now, sometimes people say, could we do this at compile time? And the answer is not yet, but by the specification, if we can actually look at your code and say, oh, there's absolutely no way at runtime this could ever work, then we'll actually be allowed to complain at that at runtime, sorry, at compile time as well. But for now, these are runtime checks. You might also actually want to take a value, but then coerce it into some other type of value. So, for example, we might know that in here, we just want to take some amount of kilometers, and maybe we read a string from input or from a file. Maybe we have some kind of fractional number, and we just want the kind of integer part. And for that, we can use this as trait here, and we just specify a type name after it. And that's just going to coerce whatever we pass into the type int. So if I actually just pass a string here, 469, it's going to be turned into an int. And you can see it most clearly here. I passed in a number, and it's actually gone and stripped off the fractional part.
Jonathan?
Yes?
What if you were to pass in a string that isn't numeric?
If you do that, it will nullify the string, which will be 0.
Okay.
Which would be
with a warning, hopefully.
Yeah. With a warning.
Which will fail.
Which, yeah. Yeah. Good question.
What happens if a type coercion fails in this case?
If a type coercion fails, then, essentially it's just going to do whatever you do if you explicitly wrote a type coercion. It's going to fail in the same way. So the signature would fail to bind, and you get an error. At the moment, no. A failure to coerce is fatal, but the thing is, the coercion isn't part of the multi-dispatch. Because when you're multi-dispatching, you care about the type of the thing you have, and the coercion is after you've decided which candidate you're going to call.
So you're already binding.
You're already binding by the time you get there.
But you could put a type on KMS that would restrict what you would accept.
Yeah, exactly. You could actually put a where if you wanted to.
Generic or
Yeah, quite. Yep. So that looks okay, but sometimes you might actually want to have a little bit more control. So you might want to say, I want to just take integers between 1 and 100. Or you might not even care what you have. You might just want it to be sort of between 1 and 100, whatever it is. And the example that I have here is, I'm taking some percentage discount, and I want it to be, in that range. So here, I can just write the keyword where, and this introduces a constraint. And then in the brackets here, I just put, 1 less than or equal to % less than or equal to 100. And then when we just pass in 20, it works. When we pass in 200, that's going to fail. And yep, what it's actually going to do is closurize that right-hand side, which is why it works. Here's somewhere that people often get things wrong. And I just like to point this out. If you write an array, like at distances, and put the type name array before it, that isn't saying what you probably think it is. All of the type names that you write before contain